G'day, I'm Aaron and welcome back to my Design, Creativity and Technology channel. I'm a high school technology teacher from Melbourne, Australia. I post regular videos on CAD/CAM, CNC, RC helicopters and other engineering related stuff. In today's video, I'm going to show you how to design and make a fabricated vise via the use of Autodesk Fusion 360, CNC and manual machining and fabrication processes. So sit back and relax and enjoy the video. Let's get started. Okay guys, so I've exported the DXF files out of Fusion 360 and I've brought them into the Plasma CAM design software. As you can see, I've nested all the DXFs together, and the reason I've done this is to minimise waste on the steel sheet. So let's press cycle start and let's watch this cutout. And then we have it. All the parts have been cut out with the Plasma CAM using a Hypertherm 65 amp. When I was cutting these out, I had it on a medium setting on about 45 amps, and it's done quite a good job. There's a little bit of dross on the back of these parts. I'm not sure if you can see that in the video. So a little bit of dross here, and we'll clean that up with a angle grinder and a flapper disc. But overall guys, I'm quite happy. How cool is that? Straight from Fusion 360 into the Plasma CAM, and I've got steel parts. Awesome. Righto, I've cleaned all the parts up using the angle grinder with a flapper disc, and as you can see, it's taken off all that dross on the edges of the steel. Now there was no need to actually grind the hell out of the parts, just had to take that dross off just so they'd fit together snugly. Now if you look over here to the right, I've started to assemble the vise. I've placed the first two components on the welding table. Now this welding table is made in Germany. It's a Siegmund table, and they're an awesome piece of kit, and as you can see, you can fixture it and clamp it up so it won't move. So when I actually start to weld, I'll weld about 4 welds in here. I won't do a continuous run. I'll put like 4 seam welds along there, and that should hold it all together. Now what I like about this design of this vise, that I've designed it in a way that it fits between the gaps in my welding table. And this, of course, being a school for students, you want to try and make this easy as possible for the kids so they all achieve their goal. Just got to work out this, watch out, this table is hot at the moment and I should have gloves on. as I was saying, guys, I'm not a ticketed welder. However, when you use a good quality MIG welder and a welding table like this, anyone can become a self-proclaimed expert. I'm pretty happy with those welds, even if I do say so myself. Now, if you're wondering what welder I'm using today, let me show you. So the welder I'm using here today, guys, is a SIG weld skilled 350 MIG. It's 3-phase, 415 volt, and it's plugged into a manifold system over here. I don't know if you can see the argon shield line, the blue tap in behind the other ones there. And I'm running about 12 litres a minute with argon shield gas. Okay, I've got the other parts clamped to the welding table. Here's the outside rails, and I've wedged that between one of these square parts here from the welding table, and clamped that together so hopefully it won't move when I weld it. Righto, I've got the all the main components welded together now for the vise, and it's sliding in nicely. Notice here that the jaws here, where the jaws locate, they slide in together beautifully. You can hear that little snap in, that little click. That's what we want. Lovely. So what I'll do now, I've got my 3mm mild steel, and this is what my aluminium soft jaws that I'll make in the hasp will attach to. And these will go in here now, and it's a matter of sliding these two parts together, back him off a little bit, putting them in here, making sure, setting them at an equal distance, and hopefully everything will be good. So what's happened here, guys, is that I tried to take a shortcut and made a mistake. Obviously, most of the time you don't see that in YouTube land because people edit it out. But what I did wrong here, instead of clamping this drawer into place, I tried to cheat, tried to take shortcuts, and it caught me out. When I welded this side, I should have tacked them both before I welded. I welded here and it's pulled this up on an angle, like so. So I'm going to have to heat this up now with the oxy and try and fix it. I'll give that little knock to see if we can move him. I think I got that, guys. Fantastic. Okay, it's all done, guys. Now let's do some CNC. Okay, here we have my assembled vise. You can see the
front jaw and rear jaw of the vise here. I'll open that up now to show you how I actually did it in the model. First of all, I drew the rearward facing jaw first, and then I mirrored it, and let's just have a look at that. We can show you as I go. And then the mirror, and then I deleted the other one. What I did then is applied some toolpaths to this. Let's just open up the CAM software, and we'll have to regenerate that, Command G, and let's simulate that now. Turn the stock option on. You'll see I'll do a facing cut, another facing cut with a 12mm OD mill to do this backward rebate. Spot drill, 5mm drill, 6mm by 1mm pitch rigid tap, and a 10mm end mill to clean up the contour. Okay, let's take it to the machine and let's have a look at it in action.
I've just pulled the soft jaws out of the Haas Super Mini Mill. Quite happy with the finish and the way they turned out. So what we'll do now, we'll assemble those in the little vise. We'll show you what they look like. Just using a couple of 6mm bolts. First one in. There goes our second bolt. We'll start to assemble the next jaw. All right. Now if I just align those a little bit and tighten them up. Now the jaw's cocked over a little bit there, but I reckon I can fix him later on. But there we have it, guys. Our little vise, at least it slides in and out. All right, let's make some of the other components.
Okay, here's my assembled vise. I've hidden most of the components to only show you the threaded shaft, the nut, and the handle. Now the reason I've done this is to make it a bit more clearer in the video. If I open up the actual nut drawing, you can see it's just basically round with two flats on it and a thread through the center. Now when I drew this, I simply drew a sketch, extruded it, and applied the other features to suit. Now usually when you're doing CNC lathe components, normally you would draw a profile and revolve it. This one is a pretty simple one, so I didn't bother about that. I'll take you into the cam and give you a look at it. So here's our cam setup. I'll just generate that toolpath, Command G on a Mac, and let's just simulate that. I'll bring it down a little bit and simulate, stock sim, turn it on. Just move this down a little bit more so you can see it. So basically here I've got a facing operation, a center drill, then a drill through the center and a part off. Now the rest of this I'll finish off manually in the manual lathe and the manual mill. But let's just take a look at this. There's our drill and our part off. So a very, very simple 2-axis part that will be machined on the Haas ST10. Let's go and take a look at that now.
Got the stock in the lathe here, and this is for the vice nut, and I've just programmed it with Fusion360 cam. Let's have a look. I'm going to set the G50 first up, so I'll jog it over with tool 1. There we have it. So going to my offset page, call up the G54 over in C, and it's as simple as pushing the button called Z face measure. Right, shut the door, fingers crossed, here we go. How cool was that? That's freaking awesome. There we have it. Alrighty. Okay guys, I'm back in on the manual lathe here at the moment, and I was too lazy to change the drill bit in the CNC lathe, so I thought, look, I need to do some manual machining anyway, so I'll just I'll do the pilot hole on the CNC. So that was a 5mm pilot hole. Now I'll run this 10.5mm drill bit straight up the center. And we're just clearing that hole out, ready for an accepted tap. And we're through. Now what I like to do, I like to put the tap into the drill chuck, and that ensures that I keep it parallel when I start my threading. Now, this isn't a machine tap, guys. This is just a standard old, it's actually a high-speed steel. It's not a carbon steel as well. It's a M12 by 1.5 pitch, okay? So therefore, to work out the size of the drill hole I needed, it was 12mm, subtract the pitch, so 12 subtract 1.5, it gave me that 10.5, all right? A little bit of oil on our bit. Now I'm not going to start the lathe because this is not a machine tap, it's a hand tap. So I'm going to lift up the chuck guard, which drops out the interlock. I don't know if you heard that in the video then, I'll just drop it down again for you. Have a listen. That little click. Now that ensures I'm not going to start the motor and kill myself, but also I'll drop the motor out here on the lathe. Here we go, just bring him up by hand, start turning the chuck. Now the first tap I'm using, guys, is a tapered tap. Then I'll go in with my intermediate, and then I'll finish with a plug. And once I go around, I'm going to back it off and repeat the process again. So I'm going to fast forward this little bit for you so you're not bored. I've finished with the tapping. I've got a plug tap here. So I've already been through with a tapered tap, an intermediate, and now it's my plug, or commonly referred to as a bottoming tap. I'm just going to start that in the thread so I know I'm not cross-threading it. I'm going to bring up my keyless chuck and lock onto that. Going to tighten it with the chuck key. And I'm just going to go really slow, guys, right down on the RPM. I'm around about 140 RPM. Now, I usually wouldn't do this. Like I said, this isn't a machine tap. This is a hand tap, but I've already tapped the thread. I'm just going to clean it out with the plug, make sure it goes all the way through. We know that's clean, and I'm right through the other side. I've just had a look. So we put it in reverse now and get it out. And we're finished. It's that simple. Now we're going to take this part over to the manual milling machine. We're going to mill 2 flats on it using a shell mill. Righto guys, I've got the part set up in the on the milling machine over here, the knee mill. I've got a set of parallel strips in there. I'll zoom in and show you so you can have a better look. Alrighty, so the part's sitting up there nicely. I've set 0 on the DRO. Now, the part is 35mm diameter. It needs to be on the flats a total of 28. So 35 take away 28 is 7. Divide 7 by 2. So I need to take 3.5mm off on the top surface and 3.5mm off on the bottom surface. Let's get to it. Righto guys, I've got my minus 3.5 dialed in on the DRO in the Z, and I'm going to use the X and the auto feed to cut through that now. Now I'm using a carbide shell mill, commonly referred to as a face mill. It's an ISCAR product, it's got 5 inserts in it. I'm going to take that in one bite. I won't go too heavy on the feed rate, it should eat it like butter. Away we go. I've turned the part over now and reset it back on the parallel strips. Make sure we give it a good whack to make sure it's sitting flush on those parallel strips. What we're going to do now, guys, I'm going to dial in the DRO to 7mm, and that gives me my 3.5 on both sides. Here we go. Up she comes. And definitely no mucking around then, guys. There we have it. Perfect flats on both sides. Ready to go, and that's our vice nut. Forgot to start the camera before, and unfortunately I missed all this manual machining part here. I may have captured a little bit here on my iPhone, so I'll stick that into the video if I can remember to do it. So what I've got in here, guys, I've got the job in the chuck. So this is actually the threaded handle. Okay, that will screw that the nut will attach to and allow the vise to be pulled in and out. The thread will live along this part here. Of using a grooving tool, I'll put a groove here as a thread relief, so when I'm cutting the thread, it will drop into that. I'm going to manually cut this thread now. I'm going to go minus 0.25. Now I was going to do this entire shaft in the Haas, in the CNC lathe, but I thought, you know what, this would be better for the students to do this manually. There's a lot of skills and processes they can obtain from doing this. So I'm leaving the half nut engaged. I'm going to reverse the lathe now, and that way then I don't disengage the half nut and I don't lose my thread. Now a lot of machinists do it this way. There's going to be a lot of you out there say, oh, why don't you disengage the half nut? The way I was taught to do it was via this method, and it reduces the risk of missing your start point on your thread. It is paramount, however, that you back off your tool when you're reversing, otherwise you'll break the tip off it. Okay, I've finished machining. I've got my shaft and the thread on it. I've got the nut. What I need to do now, I need to mark the nut where to drill in the centre, an 8mm hole in the centre, and I need to mark where the vice handle goes and where the split pin goes. And paint the top of that. Just paint that there. And at 90 degrees, I'm going to put some layout fluid there. And just let that dry for a moment. So now I'm going to find the centre of this block here. I've used the layout fluid. I'm going to go corner to corner, and that should give me the centre. So with my steel rule and scriber, now due to the layout fluid being on there, I don't have to press really hard to get a mark transferred onto my job. And as you can see there, guys, I've got lovely diagonal lines, and now I can locate the centre. Now I'm going to just stand my scriber up on that point. Again, find that point that I made previously. Okay, one hard whack. We now have the location of where to drill that 8mm hole. Let's set that RPM on the drill. So remember, 320. Now we're using high-speed steel, and we're drilling into mould steel, okay? So that's 30 metres a minute. Now let's divide that by 8mm, and we need an RPM about 1200 RPM. Away we go. Just doing a little bit of peck drilling here. Try not to get coolant on my good camera lens. And there we have it. I've got the handle set up in the V block now, and I'm going to drill the 8mm hole for the handle. I was just trying to align it there. We should be right to go. I'll have to check it as I'm drilling. Make sure I remain on centre. More coolant. We're going to drill a 3.2mm hole here now for the split pin. I always try to run coolant. The reason being, better life out of your tools, better finish to your work, and we're through. that went all the way around. It worked its way around quite nicely. I might flip it over and just check the side. Okay, now comes the hard part. Usually if you've got a second person, this is a lot easier. I'm working alone at the moment, but we need to compress that spring like so and poke that split pin through. Okay, now we're just going to bend it over on each side and we're pretty much done. There we have it. It's in there nice and tight. The spring will compress, allowing our vise to move. I've managed to knock the pin in. It's located in the nut inside there. And now this will allow me to wind the vise and close the vise. So what I need to do now is just run a bit of MIG weld around in there, and should be right as rain. That concludes the video for today. Hope you've enjoyed it. Fusion360 sheet metal fabricated vise. How cool is that? Now, I know it works. I proved the concept was done in Fusion360, of course. There's nothing like making it and just making sure that it all fits together. What I'll do now, I'm going to go ahead and make these with my students. Much, guys. Now, before I go, would you like to own this vise? If you want this vise, guys, simply it's going to be given away to subscribers for free. Put a comment in the comment section below and tell me in about 50 words why you want to win this vise, and I'll ship this to you pretty much all over the world. All right? Thanks very much, guys. Have a good day. See you later.